Solid-state drives SSD work by using NAND-based flash memory to store data. This is in contrast to traditional hard disk drives HDD, which store data on rapidly spinning disks. Because SSDs have no moving parts, they are able to access stored data much faster than HDDs, which have to physically locate the right part of the spinning disk to read the data. In an SSD, data is stored on interconnected flash memory chips. These chips are arranged in a way that allows the SSD to access them quickly and efficiently. When you save a file to an SSD, the drive's controller determines the most efficient place to store the data on the chips. When you want to access the data, the drive's controller retrieves it and sends it back to your computer. One of the key benefits of SSDs is that they are much faster than traditional hard drives. They can access stored data almost instantly, whereas HDDs can take longer because they have to physically locate the data on the spinning disk. SSDs are also more durable and reliable than HDDs, as they have no moving parts that can fail. There are several types of SSDs available. SATA SSDs. These are the most common type and are used in most laptops and desktop computers. They are connected to the motherboard using a SATA interface. M.2 SSDs. These are small, compact SSDs that are designed for use in laptops and other compact devices. They are connected to the motherboard using AM2 interface. PCIe SSDs. These SSDs use a PCI Express interface to connect to the motherboard and are much faster than SATA SSDs. They are often used in high-performance gaming laptops and desktop computers. External SSDs. They are enclosed in a case with a USB interface, allowing them to be connected to a computer as an external storage device. Enterprise SSDs. These SSDs are designed for use in servers and other high-demand environments and are typically more reliable and durable than consumer-grade SSD. Hybrid SSDs. These are SSDs that are combined with a traditional hard disk drive, HDD, to provide both fast access to frequently used files and a large amount of storage space. The speed of an SSD is typically measured in terms of its data transfer rate, which refers to the amount of data that the drive can read from or write to the disk in a given amount of time. The data transfer rate of an SSD is usually measured in megabytes per second or gigabytes per second. The data transfer rate of an SSD can be affected by several factors, including the type of interface it uses to connect to the motherboard, the type of flash memory it uses, and the design of the drive's internal hardware. In general, SSDs are much faster than traditional hard disk drives, HDDs. HDDs have a data transfer rate of around 100 to 200 megabytes per second. SSDs can have data transfer rates of 500 megabytes per second to over 3,000 megabytes per second, depending on the specific model and configuration. It's worth noting that the actual data transfer rate of an SSD can vary depending on the specific workload and the type of files being accessed. For example, an SSD may have a high data transfer rate when reading or writing small files, but may be slower when reading or writing large files. Another advantage of SSD drives is their low energy consumption due to the absence of mechanical ports and spinning motors and platters. This makes them ideal for use on laptops where increased battery life is required. Thank you for watching our video.